if D, E, and F are midpoints of the sides AB, BC, and CA, respectively, of an isosceles triangle ABC, prove that DEF is also isosceles. So this is our triangle. Okay, and DEF are midpoints. Let us call this triangle ABC. And this is my midpoint. This is the midpoint E of BC. And this is the midpoint F. Okay. We join these. Okay. Suppose this is an isosceles triangle in which these two sides are equal. Say this AB,
Good
is equal
morning,
to
sir.
AC. Suppose these two are, good morning. Suppose these two are equal, okay, in this triangle. Then what will happen? If D, E, and F are midpoints, then this two will be equal, and these two will also be equal, because if this is X, then this is also X, this is also X, this is also X, so that this entire length is 2X, and this entire length is also 2X. Okay, so that is why. That is why I have not given double sign here. I've only given a single sign of equality, because all these are equal, because I have taken AB is equal to AC. Okay, so that is why. So what I say is, let triangle ABC be isosceles. Let triangle ABC be isosceles with AB is equal to AC. Okay, that is, these two sides are equal. Okay. Now, what you can see from here, that E and F.
Good morning, sir.
Yes. Now this, good morning. This is the mid. This E is also the midpoint. So therefore, BE must also be equal to CE, right? So now what do you see from this figure? You see that E and F are midpoints of what side? BC and E and F are midpoints of BC and AC, respectively. So therefore, what can you say from midpoint theorem? Can anyone tell me what can you say from midpoint theorem? E and F are midpoints. What can you say?
So EF parallel to AB and EF half of AB.
Exactly. EF parallel to AB. Very good, Shika. EF parallel to AB and EF, the length of EF must be equal to half of the length of AB. This is what you can say from midpoint theorem. Okay. Similarly, D and E are midpoints of AB and BC. Respectively. Therefore, what can I say? Anyone wants to try? Anyone wants to try? Zishan, you want to try? If D
Sir,
and E.
I'll try.
Sneha.
Yes, sir.
Okay, tell me.
So DE is parallel to AC and DE is half of AC.
Exactly. Very good. DE is parallel to AC and DE is half of AC. Okay. So, but if EF is half of AC, then what can I write? AB is twice of EF, right? And you can
Yes,
write
sir.
this AC is twice of DE, right? But we have assumed here that AB is equal to AC, right? They have given that this triangle is isosceles, right? So since AB is equal to AC, therefore what is AB here? Twice of EF. And what is AC here? Twice of DE. That means EF is equal to D. That means, and what does EF is equal to DE mean? That means EF is equal to DE. These two sides are equal. So therefore, hence DEF is an isosceles triangle. That's it. Okay, easy enough problem. Important problem also. Next problem. Now, just a variation of this problem that is given in the textbook. Just want to repeat this, that a small variation is there of this problem in the textbook, that how to prove that DEF is an equilateral triangle, that this triangle is an equilateral triangle, given that these three sides are equal, that is, this triangle is equilateral. Then how will you prove? Then you will, what you will say here is that AB from midpoint theorem, first you will, not midpoint theorem, but you'll say that since the ABC is an equilateral triangle, therefore AB is equal to BC is equal to AC. Next, from midpoint theorem, what you can say is that AB is twice of EF and BC is twice of DF and AC is twice of DE. So therefore, what are you getting? You're getting EF is equal to DF is equal to D. So therefore, you have proved that all these the three sides of this triangle are equal. So therefore, this must be an equilateral triangle. So if this triangle is isosceles, then this triangle is isosceles. If this triangle is equilateral, ABC, all three sides are equal, okay, then this triangle, the inside triangle, will also be equilateral. So there's a variation of this problem in the textbook itself. So you can refer here if you're solving that problem, then you can do this. Let us look at the next one. In the figure given below, D and E are medians. Okay. What do you mean by median of a triangle? Have I discussed median with you? I think I remember discussing medians. Can you tell me what is the median of a triangle? Can anyone tell me what do you mean by median of a triangle?
So the midpoint
Midpoint what?
of a line.
Is the midpoint
Of
called the
line.
median? Midpoint is not called the median.
So midpoint drawn from each side.
Not only, not side also. A line segment is called a median. What kind of a line segment? From a vertex, from say from A. If I am drawing a straight line joining the midpoint of the opposite side. Okay, this is the midpoint of the opposite side. That means this must be equal to this. This line segment here, let us call this AD. Let's call this point D. So that this line segment here is called the median. Okay, so when you are drawing a line from a vertex to the midpoint of the opposite side, then that is called the median. So if AD is a median, then D must be the midpoint. Okay. Similarly, this line segment is the median. From B, you join the midpoint of the opposite side. This is the midpoint, so therefore you mark this. Okay, so this is the midpoint. Fine. AD and BE are medians of triangle ABC. DF parallel to BE. So which one is E and which one is F? So this is DF. Okay. So DF. This there's a line here that they have called DF. Okay, and they have given that these two are parallel to each other. DF parallel to BE. Okay, so these two are parallel to each other. They have given. You need to prove that CF is 1/4 of EC. Very interesting problem here. So if this is the midpoint, D and E, if they are the midpoint, then what will happen? What can I say? If these two are the midpoints, look at this triangle. Look at this triangle. Right? In this triangle, you see that D is the midpoint of the side BC. Also, this line is parallel to this side of the triangle. Do you agree? Do you agree or not?
Yes.
Can you
Yes,
see the
sir.
red triangle? In this red triangle, D is the midpoint of one side, which is BC, right? D is the midpoint of BC of this triangle. Also, the straight line through the midpoint is parallel to one side of the triangle. Okay. Then what can I say about F? What conditions are satisfied? Are the conditions of midpoint theorem satisfied, or are the conditions of converse of midpoint theorem satisfied? Which theorem is satisfied? The midpoint theorem or the converse of midpoint theorem?
The
Yes,
converse.
the
Converse
converse
theorem.
of midpoint theorem is satisfied. So therefore, I can say if the converse of midpoint theorem is satisfied, then I can say F must be the midpoint of this side, EC. Okay. So what I do here is I write in triangle BEC, D is the midpoint of BC and DF parallel to BE. Therefore, F is the midpoint of EC, right? And this is by
Converse of midpoint.
the converse of midpoint theorem. Okay. So we have proved that F is the midpoint. What do you have to prove here? We have to prove CF is equal to 1/4 of AC. So we start from CF. CF is equal to. Now what is CF here? We have proved that CF is the CF is the midpoint. So CF must be half of CE, right or wrong? Because F is the midpoint of E and C. F is the midpoint of EC.
Yes, sir.
F is the midpoint of EC as shown above. As shown above. Okay, this here we have proved F is the midpoint. So that's why we can write CF is equal to half of CE. Now what can you see about CE? You see that E is the midpoint of AC. So CE must be half of AC. Since E is the midpoint of EC as given. Right or wrong? If E is the midpoint, then it must be half of, then this length, CE must be half of this entire length. So therefore,
Yes, sir.
CF will be half of 1/4 of EC. So that is done. Proof. Okay, that was simple enough. But here in this problem, we use the converse of midpoint theorem. Instead of using the midpoint theorem, we use the converse of midpoint theorem in this problem. Let us look at the next problem. In this figure, ABCD is a parallelogram. Okay, so let us draw a parallelogram here. ABCD is a parallel. E and F are midpoints of the sides AB and CD. So this is your ABCD parallelogram, and E and F are midpoints of AB and CD. E is the midpoint of AB, and F is the midpoint of CD. Fine. The straight lines AF and BF meet the straight lines ED and EC. Fine. So there are straight lines drawn. These 2 points are joined. This is joined, and this is joined. This is joined, and this is joined. Okay. And this is called G and H. Okay. Now the question here is that prove that HEB is congruent to HCF. HEB is this triangle, and HCF is this triangle. You need to prove that these two are congruent. So I think that should be fairly simple. Let's see. First of all, these two angles are equal, right? And again, these two angles are equal because why? They are alternate angles, and you need one side. So which side can it be? Which side can it be? So if you cannot see any side, then what you must observe here is that AB must be equal to CD, right? Because opposite sides of a parallelogram are equal, right? But what is AB? AB is, it is given that E is the midpoint. So therefore, AB is twice of EB. Am I right? F is the midpoint of CD. So therefore, this length must be half of this entire length. That means this entire length must be double of this length. So you can write this as twice of FC. The reason here is since E and F are midpoints of AB and BC respectively. So that means what have we shown? We have shown EB is equal to FC. So actually what we have shown that these two sides, this side and this side, they are equal. So therefore in these two triangles, the angle that I have marked in red and green, they are equal, and these two sides are equal. Therefore they must be congruent. Okay, so let us write in triangle HEB and triangle HCF, angle HEB is equal to angle HCF, angle HBE, angle HBE must be equal to angle HFC. The reason for both are same, they are alternate angles. Okay, and above here, what have I proved? EB is equal to FC, as proved above. So therefore, these two triangles are congruent. Now you're going to tell me the axiom. Okay. By which axiom? So these two angles are equal and these two sides are equal. This side and this side and this side. They are equal. Okay. Now tell me which axiom?
So angle
So
side angle.
angle side angle.
ASA, because the side that we have proven equal is nothing but the included side. That's why. So ASA axiom. We have proved the first part is over. That you have to prove that these two are congruent. We now move on to the second part. The second part is prove that this quadrilateral here, GEHF, is a parallelogram. If I can show that this side is parallel to this side and this side is parallel to this side, then I can say that it is a parallelogram. If I can say that opposite sides are parallel, then I can say it is a parallelogram. But how to prove that opposite sides are parallel? Look at this very carefully. How to prove that opposite sides are parallel?
SAS.
SAS. Where does SAS suddenly come from? SAS is over. SAS, ASA, EAS, everything is over. Okay. Look at this triangle first. Look at this triangle. You know that F is the midpoint, right? Of which side? DC. Is H the midpoint? Is H the midpoint of EC? Is H the